Okay, we have one more example we want to do, and you'll have some of these on tests. And you need to know how to do these. Geometry, after all, is about you being able to graph this stuff on a grid, two-dimensional, three-dimensional space, and then find out from those points what's going on. Okay? So what we've done is we have a figure. We have a quadrilateral. We're given a quadrilateral. We have four vertices. R is at -1, 2. S is at 5, 0. T is at 4, -3. U is at -2, -1. Is that right? Yeah. Okay, I think that's right. Okay, so what I've done is I put up a little piece of graph there. All right, and we've graphed it. It's not perfect, but you're going to get the idea. In black is our graph, in red is our figure, and in purple is the right triangles that I drew that will show us what our slopes are, what our rises and runs for each segment are. So what I've done was, I've looked at the slope of UR, segment UR. So I'm going from U to R. How much does it go up? Well, it goes from, U goes from -1 to 2. How far is it from -1 to 2? It is 3. So our rise, our delta Y, is 3. What's our run? Our run goes from -2 to -1. Well, that's 1. That's a positive 1. So our slope on UR is 3 over 1. Delta Y over delta X. Delta Y over delta X is extremely important critical calculation. We don't push it too much, but we're going to need to push it a whole lot more. That's called slope, delta Y over delta X. In calculus, that becomes dy dx, and we use that extensively. Let's look at the slope of the opposite side, or what we think is the opposite side. So what is the rise between T and S? Well, it goes from -3 to 0. Well, that's going up 3, positive 3, isn't it? Well, what's the run from 4 to 5? That's a positive 1. So the slope of segment TS is 3 over 1. Well, wow, those two have equal slope. What does that tell us about those two? Two line segments have equal slope. What do we know about? Come on. Yep, that's right. They're parallel. Okay, so these two are parallel. Wow, we've got half of our parallelogram, don't we? It's got to prove the other side. Now let's look at R to S. What's the drop from R to S? Well, it drops from 2 to 0. That's a negative, so that's a -2. What's our run from R to S? Well, that's a positive from -1 to 5, so that's a positive 6. So our delta Y over delta X is a -2 over 6. How about from U to T? It drops -2. It runs positive 6, the same thing. Got that? So these two are also parallel. So we have a parallelogram. Now, let's look at this real close. This right here and this right here. If we multiply those together and we get a -1, what does that mean? Come on, what does that mean? Multiply the two slopes of two segments together, and if the product of their slopes is -1, that means they are perpendicular. Or if they are the opposite reciprocals. Well, let's do that. 3 over 1 times -2 over 6. What's that equal? -6 over 6. Wow, that equals -1. So that tells us that these two lines, sets of lines, are what with each other? They're perpendicular. Opposite sides are parallel. Opposite sides are, consecutive sides are perpendicular. I think we got what kind of figure? Well, this sucker just looks like a rectangle. Okay? What's the area of a rectangle? Length times width equals base times height. So all we got to do is find out what the length of each one of these is, and we'd be home free. Well, we've got it set up. We've got 3 over 1. So we should be able to do Pythagorean theorem. Square root of equals, that's 9. Okay? So we've got the square root of 10 for that one. Oh, we've already got this over here, so that is square root of negative 2 squared plus 6 squared equals, that's 4, plus 36, square root of 40. I don't know, the area is going to be what? Square root of 10 times square root of 40. Anybody tell me what that is? Looks like that is 20. So our area is 20. Okay? We know what each side is like and whatever. Okay, so this one is a little more complicated. We're asked to plot it. We're asked to find out what kind of figure it is. We're asked to find out, what's the relationship between the sides. We did all that. We found out that, wow, the opposite sides here are parallel. The opposite sides here are parallel. Found out that not only are these sides parallel, but they're also perpendicular to these other sides. So that makes that a rectangle. The area is just going to be the length times the width, or the base times the height. We figure out we've already got this that we can use over here to find the length of that one. We've got this here, so we can find the length of that one. The area is going to be the square root of 10 times the square root of 40. And away we go. Okay? Areas of parallelograms, and being able to determine what a figure is by plotting it on a graph and using it. That's area of parallelograms.